Good morning, everyone. This is CactusCon, track 1, first talk of the day, with Ryan Thompson, Clearing the Fog, Detection and Defense Against Cloud Persistence. Thank you.
Thanks. Appreciate the introduction. I also appreciate all of you. 9:30 is a hard time slot to hit on day 2, so thanks. It's also a pretty competitive time slot. I know there's some other good talks going on, so I'll try to set the scope for what I'm going to talk about, and if this isn't the right talk for you, you can probably still catch the other ones. I want to make sure we're in the right spot. So first off, who am I? I have worked in the cloud space for about 5 to 6 years, in various capacities. I've done threat hunting, detection engineering, and then even the sexiest of the 3 up here is auditing, obviously. And so I've been in this space for a while, predominantly in the AWS space. Currently, I work as a senior cloud security researcher for a pretty major security vendor, trying to figure out how you hunt in the cloud across the control plane, across hundreds or thousands of customers, which presents its own challenges. So, what are we going to talk about? Well, more importantly, what are we not going to cover? I want to make sure we set expectations right out of the gate. We are talking about persistence, but when I talk about cloud persistence, I'm not talking about this host happens to live in the cloud, how do I persist on that host? Nothing host-based here. We're also not going to talk about how do we defend against these things. We'll talk a little bit about detection near the end and some ways that you can reduce your blast radius, but we're not really defense-focused talk. I'm not going to tell you what policies to put in place or what service control policies you need. And the last piece is we're going to be talking about a lot of API logs. We won't really be covering log parsing or ingestion. That's on you to figure out how you want to review CloudTrail logs or audit logs from Azure. That's 100%, you kind of choose your own adventure there. So what we will cover is going to be persistence mechanisms specifically for the cloud control plane. So quick raise of hands, how many of you are working with Azure or AWS? I assume it's a pretty good number, okay. And really what we're talking about is somebody's gained access either through the console or through access keys to your environment. How do they persist in that environment, that control plane space? And the other piece is we're going to be talking about hunting and monitoring strategies for these various types of behavior. So this is what I hoped this talk would be about. Equal parts AWS, Azure, and GCP, but as these talks evolve, you realize sometimes that's not going to fit into a 40-minute talk. Sometimes you realize these cloud technologies are too far away from each other. So here's a much more realistic view of what today's talk is going to cover. So if you're here for GCP, you're out of luck. Their identity is too far different than the rest of the other two. And then Azure follows a lot of the same behaviors that AWS does, but this is kind of where my experience lies. It's a great representation of my knowledge as well. So we're going to focus on AWS, pivot over to Azure, and show the equivalent. So here's what our schedule looks like today. We're going to briefly talk about the cloud, just a quick primer. We're going to talk about permissions in the cloud specifically, because that's crucial to maintaining persistence. Everything is a permission. We're going to go over some real basic persistence mechanisms. At this point in the talk, you'll probably be like, yeah, okay, creating a user is obviously a persistence mechanism. But don't worry, we're going to get more advanced in that next section, and then we'll wrap it up. So starting off with the cloud intro. For those of you who aren't super familiar with the cloud security space, I'm going to cover the 3 most common ways that people get into the cloud. And so first up, you have an instance breach. So what's happening here is you have a server or some kind of infrastructure out on the public internet. They gain access to that box, and on that box there are credentials. They then use those credentials to pivot into the control plane. And so this is pretty common. We're not going to get into all the different ways that you can breach that box or how server-side request forgery plays into it. Just know that is an avenue. The next one, also a very increasingly popular one as more people move to these software as a service and start putting their code and a lot of their secrets in other services, sometimes in an insecure manner, is leaked credentials. So maybe they put it in a GitHub. Maybe they uploaded a script that was supposed to be for dev. It actually went into a public repo, and it had some AWS API keys in there. It's absolutely going to get scooped up and used. Last but not least, session hijacking. So I'm logged into the console through my browser. My browser has an exploit, and they're able to pull session cookies for my credentialed login and leverage those as temporary credentials. This is honestly the least common out of the three, in my opinion, but absolutely an avenue. So we're going to assume this breach. One of these three things happened and an attacker has landed in your environment. How do they want to make sure that they can persist there? So in order to persist in a cloud environment, you don't create a cron job, you don't create a scheduled task, you don't maybe have I don't know, some kind of run command that runs at the beginning of each login. You do it through permissions. So let's chat about that for a second. This is a very simple question, you would think. And this question came from one of my fellow researchers. They are not working in the cloud space. I was showing a demo, and they asked me this simple question: does this user have admin? And if you've worked in the cloud, you know this is a very complicated question to answer. It's not like it is on the host side. It's not like somebody either has root or they don't. Permissions are granted through policies. So whenever you're accessing the cloud, you're doing it through one of two ways, generally speaking. One is the AWS console, or in this case, a web console, could be Azure as well, or it could be through the CLI. Both of those need credentialed access and certain permissions to do a task. The logs look almost identical. Really what changes is your user agent. So nothing crazy there. These permissions are usually granted in a JSON document. It's going to go through and say, this is what you're allowed to do. Here's the resources you're allowed to do it on, and you apply that through various methods. So we can attach those policies directly to a user. We can apply them to a group that contains multiple users. Or the most complicated one is we can use a role. And so I want to talk about this a little bit because it's crucial. A role I think of as a hat. It's a hat that you can wear. That hat has permissions, and on the inside of that hat, they write down who can wear that hat. And so this is what's called a trust policy. And so down here we see this role has certain policies associated with it. Here are the two users that can wear that hat, and there you go. You have nice little Cowboys hats on user 1 and 3. So these are really the basic mechanisms for how you grant permissions in the cloud. So it's crucial to understanding these next few sections. So when we talk about persistence, there's really two major avenues. I either want to create attacker-controlled infrastructure or identities. So maybe that's a new key that I create that I have access to. Maybe I'm spinning up a new instance. Maybe I'm creating a new policy. I'm creating something from nothing. The alternative is I'm going to build a backdoor into existing identities. And so as we go through here, keep in mind, it's going to be one of these avenues. So some basics, just to really set the stage here. These are some basic persistence mechanisms. Some people may walk away with something from this portion, and that's great, but most of you have been in security for a while. This is going to be a huge surprise, but we need to cover the basics. So I'm going to go through a lot of API calls, and I'm not going to go into them into detail. I'm just going to mention what the event name or what the action is in Azure. If you want, you can scan this QR code. I promise it's legit. You can go there, and it's going to list out all of these as a reference, so you don't have to go and actually jot all these down as I'm going through it. So I'll leave that up for a few seconds. I see some phones coming out. But in theory, it should allow you to watch the talk instead of having to type things into a tiny notes app. It's going to be a better way to do it. I'll also pop this up at the end, so if you've missed it, that's totally fine. So, persistence option 1, I can create a user. And that sounds like, oh, well, that's great. You're done. You've created a user. But by default, that user has no permissions. We need to attach it through some mechanism. So if you create a user and you say, great, I can log into that user whenever I want, and you walk away, when you log back into that user, you're going to get some real sad console logins. A lot of access denied. Azure is going to pretend it's never seen you in its life. It's going to say, welcome to Azure. We have all these great things. Please sign up for Azure. And so at this point, there are no permissions actually associated with that user. So step 1 is create a user. Step 2 is somehow get a policy associated with that user. In Azure, it's called a role, but it's very similar. We're looking at attaching permissions directly to that user. So we have a couple ways to do that. Here are the API calls. In orange are going to be the AWS. In blue are going to be Azure. Pretty straightforward. We're going to create a user, and we're either going to attach a user policy or add a user to a group that has permissions associated with it. So once again, super basic here, but this is a good starting place. As we get a little bit more involved here, I want to take a look at alternative authentication methods. So in AWS, you have one of two authentication methods at a basic level. You have console login, so that's going to be username and password. I can punch it into a browser. I'm navigating the GUI. I'm good to go. The alternative is a set of API keys that I can build into my code, drop publicly into GitHub if I want to. I can interact through the command line. And so usually, a user has one of these two. If you have a well-architected environment, you probably do it a little bit differently, but ideally it's one of these two. Either I'm using this to navigate, maybe to handle billing, maybe I'm a new user, I'm using the console, whatever that may be. And then I have my automated accounts that are going to be using CLI. That opens a door for attackers to establish persistence, and they can create the alternative method. So if I have a service account or what I'm using as a service account through API keys, and that's how it typically authenticates, if I create a console login, now I can log in as that service account, and maybe nobody notices. More importantly, that console access doesn't exist day one, and so I can go create it, and if I don't have good monitoring set up, all of a sudden I've got a direct path into that environment. So here's what they look like. If I'm looking at a GUI user and I want to create an access key, it's pretty straightforward. It's called create access key. I can request it for a specific user. It'll spit out those access keys that first time, but they're no longer retrievable. So if I create those access keys, I've got both the access and the secret key. I'm good to go. If I do console login profile, if I create one of those, I can actually set the password right there. It won't be visible in the logs, but I can set that for myself. Azure works a little bit differently. They have users and service principals. Very similar methodology though, right? There's going to be console logins and there's going to be CLI access through API keys. Now, the thing I've noticed about some service principals is you can create quite a few access keys with that, and so you're not limited, but those are going to look very similar. So I can create those. I can create as many API secrets as I can. So in AWS, a user can only have 2 API keys active at any time. So if those 2 are used, I can't really create a third. Azure, not so much. You can create as many as you want, which is it's kind of bonkers to me, but they do have expiration dates on them. So you can set them to expire over a period of time. So it's, either way. Here are the API calls used for these. Once again, these are all in the reference. So these are API calls I would understand in my environment and know what to look for. All right. We're going to go back to the hat analogy. We're using a top hat this time instead of a cowboy hat, but the kind of intent remains the same. When I want to set up cross-account access in an AWS environment, I create a role, and let's say Steve wants to access my AWS account, and he has his own account. Well, what I can do is I can create a trust policy that says Steve can wear this hat, even from a different account. And so what we have here is an example of a legitimate user able to put these permissions on. But if I can give that cross-account access to somebody I trust, I can also give it to somebody that I don't trust. So if I can gain access and add myself to a trust policy, all of a sudden, I don't even need to authenticate against your environment. I can just assume that role. I can wear that hat, and I can walk around in your environment and do whatever that set of permissions allows me to do. And so this is a fairly common method of persistence. It gets a little bit more advanced when we start building it into some Lambda functions and some other things that we'll talk about in a second. So from here, obviously I just notify me whenever somebody uses my AWS account that isn't in my account, right? It's that easy. It's not, unfortunately. If you have an AWS organization, you have multiple accounts, you're going to have cross-account activity all the time. So maybe you have your prod environment set up, but you allow a few of your security users to have read-only access to your prod for investigative purposes, right? So that trust relationship will be there. The other piece is if you have vendors. All these vendors up here have cloud, and more specifically AWS offerings that require that cross-role permission. So you're not setting up a user inside your environment for Databricks or Qualys. You're setting up a role and saying, hey, this hat, this is for Qualys. It can wear it. So you'll have to build some exclusions around that, so just be aware. And here's what an update assume role policy looks like. The event name is pretty straightforward. The policy document associated with it, log, is a mess. It is string formatted JSON. A lot of SIMs will be able to handle this, but you may have to do some conversion. You'll have to use regex to extract the account IDs and kind of figure this out. This is actually a great way to catch that cross-account activity. I was working for a client and I set up some rules. We actually were able to catch a few POCs being launched by other development teams. I think they brought in Orca security, they brought in Dig security to test things out, and they had to set up these cross-account roles, and they didn't let the security team know. And so we were able to catch those pretty quick. Luckily, they were legitimate. So once again, the afterthought of Azure has something similar. They do it a little bit differently. You can set up a guest account, which grants cross-account access within Azure. So there's 2 steps to this. The first step is inviting that external user, and then there's a log that's generated once they redeem it. I would recommend setting up an alert whenever the invite goes out. I don't really care if it was redeemed or not. I want to keep track of who's being invited to my organization. I take that back. I do care if it's redeemed, but I definitely care that they're sent out. Those are 2 sides of the same coin for sure. All right, let's get into the fun stuff though. These are some pretty basic ones. We've set up some accounts. We've created cross-account access, but let's get into some more of the fancy stuff. So first step is going to be what's called an instance backdoor. And so, I've talked a little bit about instances being a way that attackers get in. Maybe they breach it through some vulnerability. There are credentials on that box, and they're able to pivot from there into the control plane. And so this is the exact same path we're going to take, except we're going to set up the infrastructure as the attacker. So I'm going to set up this new instance, and in order to access it, I've got a few different options. I can create a brand new SSH key as an attacker. Now that SSH key is only downloadable when it's created, and so I won't be able to actually pull that back up from the console, but if I'm the attacker, I create it, I have that key. The alternative is importing or uploading a local SSH key. So I've got a key that I generated, I want to use it. And the last one is, hey, I've created a key, this is the key we use for all of our instances because we have terrible security practices, I'm just going to use that key again. And so those are the 3 options that you have. So if I'm an attacker, I'm creating this, I'm probably using one of the first 2 options. I'm going to create this instance, and I'm going to maintain access over SSH. The next step is you add a role to this instance. You give this instance permission to do things. And the reason this exists in general is if I'm developing something legitimately, if I need my instance to reach out and grab things from S3, or I need it to reach out to a database, whatever that may look like, there's legitimate reasons to add permissions to a role. It happens all the time. It's kind of the core of how EC2 in AWS works. But if I'm an attacker, I set up this role, or I set up this instance, I put a role hat on this instance and say, hey, you've got some pretty strong access. Maybe it's complete access if I've got the right permissions. And so from there, I can SSH back into that box and then hop back into the console. And you may think, if anyone here has played around with AWS, you're like, I've got 12 instances. I would know when there's a 13th instance. It's not really how enterprise environments work. We're talking thousands of instances per region. Maybe you even create this in a region where people aren't looking. And so think about that when you're setting up monitoring. Should you have any instances spinning up in the APJ region? Probably not, depending on if you do business there or not. So just keep that in mind. Once again, I have a really fun list here of API calls. Keep in mind, they can't do this without having access to these API calls. We'll talk about that later. So it's not like they gain any foothold and they're able to do all these things. This is why reducing your blast radius matters. So we'll catch up with that at the summary there. Once again, the equivalent for Azure, it's generating an SSH key or updating a SSH public key, and then creating that role assignment and creating a virtual machine. It's the same steps for Azure. They just use different names. You'll notice that I'm using 2 different versions of the action for Azure. Depending on if you're looking on the console or if you're exporting those logs out, they can appear differently. Azure is all kinds of fun with its consistency, we'll say. All right, so quick primer on AWS Lambda. This is when we start getting away from the manual configuration of infrastructure or permissions and more leaving some type of automation behind. And so what Lambda is at its core, it's really AWS's basic serverless offering. And it's not really that fancy. It spins up an instance, it runs some code, and it spins that instance down. That's really all it is. And there's a ton of different languages that are supported. If you're like me, you just always scroll down and pick Python because that's just what I'll die with as somebody who's not in the development space. But they offer a ton of different options. And it's not very complicated, it really isn't. You have a Lambda function that you grant a role to. You have code associated with that Lambda function, and then you have a trigger. If anyone has ever used if this, then that, that's basically Lambda at its core. It's not quite as drag and drop as if this, then that, but it's very similar. So what can an attacker do with this? Well, there's a attack or a post-exploitation attack framework called PackU, and they built an amazing module for this, and I'll go over it in just a second. If anyone hasn't played with this tool, I think there's 2 people in this room that I attended your talks that talked about PackU, so we're at least up to 3 at this conference. So doing pretty good with PackU. It's got some good representation. It's built by Spencer Gitson. He was a brilliant researcher for Rhino Security Labs. Unfortunately, he passed away at a very young age. I just want to give credit where it's due. This platform is amazing. So it requires some type of access keys, and it can launch different types of attacks. The one we're talking about is a Lambda persistence module. So the idea here is our trigger is a new role created. So we've created this new role. It's sitting here. It's got permissions. And maybe I'm using that for maybe one of my development instances. Maybe I'm using it for a production instance. Maybe I'm granting this to, it could be anything, quite frankly. So me, legitimately, as a user, I've created this, and that is the trigger. Code will run whenever a role is created, and what happens is the code tells me to add the attacker's user to this trust instance. So let's step back and think about what that means. I'm an attacker, I've gained access to your environment, I've created this Lambda function, and I've walked away. Maybe I didn't have quite the access to the things I wanted, but I was able to create or modify a Lambda function. So I set this and I walk back. Now, your legitimate developers or legitimate engineers are going to come in and create roles, and automatically that attacker will be able to wear that hat or assume that role. And so unless you're looking at your Lambda function and knowing what's happening, you may not understand how they're getting persistence back. There's no API calls that are made externally. These are all made internally from AWS. And so we'll cover how to detect this kind of stuff in a second. And yeah, now all of a sudden the attacker is wearing the cool chef's hat. They're gaining access to your environment. So I looked at this and I said, this is awesome. How can I make this more complicated? Because that's what we tend to do in this industry. And so within Lambda, there's an ability to create a function URL is what they call it. And so this is a URL that you can go to that triggers that Lambda function. So instead of it being automated, it's kind of manual. You click on that link and it fires whatever code is there. That's kind of interesting. It can be useful for a variety of different things. But what's more interesting is I can add parameters to that Lambda function. So all of a sudden, I create this Lambda function. I don't set an official trigger, but I do create a public-facing URL, and I walk away as an attacker. So what that does is it gives me the ability to launch that Lambda function whenever from a very unique URL. So I've got that in my pocket, and I walk off. What I can do, though, is I can add parameters to the end of that URL and have the code do different things. So I set this up, I give the Lambda function adequate permissions, and what I've essentially done is I built a C2 framework within this Lambda function. And so now I can go back to my browser as an attacker, months or years later, I can go to this URL and I'm gonna get an error. That's totally fine. But I can go at the end and I can type in type equals help. And this pulls up a help function for me. So this is something I've built into the Lambda function. And so what's happening here is there's really not any API calls being made at this point other than the Lambda function running. But I can go in and I can say, hey, can you give me the help page? And the Lambda function runs its code and spits out this string. So far, nothing crazy. But I can change that. I can say, okay, well, I got some options here. I want to list users. And so I can type this into the parameter up here. Is going to make an API call from Lambda, and it's going to list the users. And so from a defender's perspective, which is the seat I normally take, what does this look like? This is a Lambda function that exists in my environment listing my users. Maybe that's normal, maybe it's not. But it's not coming from me, the attacker's IP. I'm making Lambda do it for me. So I can do more with that, though. I can expand this to do whatever I want, really. At this point, you can see I clearly gave this a B-sides Denver. I can go and I can create access, or I can list access keys for a specific user. Once again, I can build this to do whatever I want. I kept it focused on persistence, but I can say list user keys for this service B-sides Denver. It's going to list the keys that exist, so it looks like I've got one key. That gives me an opening to create a second key. You'll notice that this API key right here only gives me the access key and not the secret key. So I can't use this key yet, but I can create a second one. So instead of listing the users, I'm going to create a key for this user. All of a sudden, I've got access keys created for this user, access key, and the secret access key is over here. And so it's just a different way to maintain persistence that gives you a little bit more control over what's being ran. So you drop that in the environment, you walk away, you can come back whenever you want. Here are the API calls required to build something like this. You need to create a function. The 2015 tag on here is a little odd. That's just the version of Lambda or the version of the API call that's being ran. I assume that they really had an idea they were going to update it more often than this, but this is kind of where we're at. We do create the URL config or the function URL, and then we update the assume role policy, right? We have to put a hat on that Lambda function. We have to put the permissions on that function to be able to do whatever we've designed it to do. In this case, list users, list keys, and create keys. Now, how do we detect this? It's pretty easy, actually, to detect Lambda functionality in your environment. If we're looking at API keys, we can see in the user agent, AWS_Lambda. And most of the time, I would say user agent is a weak way to actually go about doing things in terms of detections. But in this case, because it's spinning up from Lambda, it's actually pretty good. I'm not going to sit up here and say there's not a way to change that. I haven't done the research into that, but out of the gate, that is a box that is controlled by AWS that is spun up temporarily to run your code. I think it'd be complicated to do, to say the least. The next question is, what do you expect your Lambda function to do? Do you expect it to do IAM activities? Do you expect it to spin up instances? I can't answer that for you. I can tell you that if you're building this detection for a single environment, it's much easier than building across hundreds or thousands of environments. When you're doing that for a vendor on behalf of a huge customer base, this becomes really difficult. If you're doing it for your own environment, it's much easier because you can take a look historically at what Lambda's done, build guardrails around that, and it'll alert you when something goes kind of out of the ordinary for that. Azure has something similar called runbooks. You can build a very similar persistence mechanism there, and you do create a URL for that as well. And so you can see we're generating a URI for this Azure automation webhook. We're creating a runbook. It's a lot of the same things, just different language for Azure. And so it works very, very, very similar. Now, I haven't built out a full C2 framework for Azure, but in theory, you're still running code. You can still grant that runbook permissions. It's all the pieces are still there. So, in summary, what do we do about this? Right? We've gone through a bunch of different persistence mechanisms. We started at user creation and went all the way down to some more advanced automation work. So, what are the next steps? You have your initial access vectors. And so, good news, it's actually really easy to stop this. You just don't let your instances get breached. You stop developers from uploading credentials into their code, and then you stop users from clicking on links. It's actually really, really easy. It's not, right? It's actually really hard. So we're going to assume these things are going to happen. That's not where this talk is focused on stopping. There's some mechanisms you can put in place, but that's outside the scope. So we have this list of API calls. It's not great. I changed this to a light mode presentation last night, and the orange does not have great contrast, but that's okay. We've got this full list here for both of these. Now, what's interesting about doing security in the cloud is these API calls serve two functions. First of all, I can go detect these activities using these API calls. The other side of that coin, though, is these are the same API calls that are going to exist in permissions that will allow an attacker to do these activities. So it's actually really nice, whereas within a traditional security space, your indicators are much different than the actual permissions that are needed. They're almost decoupled. So what do? We need to limit our blast radius. We're going to assume that that identities will get breached. And what we see in the cloud a lot is the cloud is complicated, it's new, it's spooky. So what people do is they're trying to get something to work. They just want to see the API call get sent successfully, and they end up building policies like this. EC2 equals asterisk. That's wide open access to to the entire EC2 service, and they can do any activity. And I don't blame people for building things this way. I used to build things this way. It was in a lab environment, not production, but I can guarantee you this happens in production. A better way to do this is to restrict your policies to exactly what you need. And so over here, we have a much better written policy. This is saying that you can associate an instance profile. That is the action you can do. It's a single action. And the resource over here is an asterisk, but over here we specify the exact resource we need with an asterisk on the end. So any instance starting with the name district. So much better way to do that. And then on top of that, you can create conditions. This one in particular says MFA must be present for this to work. You can even have these expire after a certain amount of time. There's all kinds of things you can do with conditions. So when we go back to auditing, right? Like I said, this is a sexy part of security. How do you audit your environment? It's actually pretty difficult to do in AWS in a lot of cases, but they're building tools to make it easier. So when I go to look at a role, so this role's been created, maybe I made it overly permissive, and I want to pull those back in. AWS has built a functionality in that says, hey, we're going to look at the last 90 days of CloudTrail. We're going to see what activities it's done and what resources it's done it against, and we're going to build you a policy based on what it's actually using, not what you've granted it. And so that's a huge win. That's a great starting place. Maybe it's not 100%, maybe you have to tweak some things, but that's a great start. There's also some third-party tools. I built something for an engagement that I have posted up on my GitHub that basically goes through and it takes a look at users, groups, and roles within an AWS environment. And it says, it's a little hard to read here, but you can say, hey, this policy here, it has a role, this policy is attached to a role, and here's the trust policy. Hey, this policy is attached to multiple instance roles, and here's the policy. And what it does is it looks for things that are overly permissive. So in this case, we see the action is ECR asterisk. In this case, it's ECR asterisk. Down here we have, let's see, oh wow, this is a fun one. RDS asterisk, S3 asterisk, all types of services wide open, right? So it said this is a sketchy policy. Where is it attached at? So we see it attached to all these users, and also spits out when the last time those access keys were used, when the last time the console login was used. And so having something like this is incredibly powerful because doing it by hand is not fun. We have a lot of clients that have tens or dozens of AWS accounts, and if you're doing this manually one by one, it can be pretty burdensome. So with that, I'll open up the floor for questions. Yeah, so the question was, I talked about breaching an instance and getting into the cloud via instance with the permissions that are there. And the question specifically was, do I see less of that with instance metadata version 2? So for those of you who don't know, instance metadata version is a way for an instance to gain access to information about itself, metadata, if you will. And part of that metadata is credentials. And so what version 2 introduced is basically a protection for machines with server-side request vulnerability, server-side request forgery vulnerabilities. That's a mouthful. It basically blocks that. So in version 1, if I could make that server send a web request, I could probably get it to give me the credentials of that host. That's what that means. Version 2 disallows that. Are we seeing less of it? I don't have the numbers on that in front of me. But one thing to keep in mind, while version 2 does a great job of stopping an attack over the network, if I gain access to that host, any user on that host can still pull the instance metadata. And so it's not a foolproof, but I have to assume it's gone down some, to your point. Now, What I can say, though, is across our customer base, we have about, I think it's, last check is 28% of the instances being spun up with version 2 required. And so what that means is a lot of machines are still being spun up with version 1. We can talk about it more, the challenges of that, but it's not as easy just flipping the switch on, right? By the way, instance metadata version 2 has been out for 5 years, and we still have, 60, 70% of our instances being spun up without it. It's wild. Hopefully that answers your question. It was a bit rambling. I had to add some context to it. Does anyone else have any questions?
So in the DevOps world, there's a lot of CI/CD, and people are starting to use things like Terraform, all that type of stuff now. People are having trouble dealing with like multi-factor authentication with automation, right? So they're just kind of like skirting it, or like what is the proper solution to that type of stuff?
So the question was, with DevOps being more prevalent, more CD, CI, I think that's right, CI/CD, not my world, very clearly, sorry, being used, what is the proper way to pass credentials across? And there's some services, things like Cognito and Secrets Manager, having some way to get away from hard-coded credentials or even anything you have to put in the variable space or into the code itself is going to be ideal. I don't know how you would handle MFA with a DevOps pipeline. I'm guessing that option is going to be Secrets Manager, but I would look into that. Not my background, I apologize. Great question, though. Any other questions? All right. I'm giving it the long enough amount of time. Thank you, everyone, for showing up for this talk. I really appreciate your time. How's it going, man?